Let's introduce the Hearbleed vulnerability, which should have been discovered through static analysis. For those of you who are very technically minded, I'll refer you to the URL on the slide, where you can read about the vulnerability in detail, or you can explore the common vulnerability enumeration listing, which provides details on the vulnerability and discussions on how to test for it. An explanation follows in the next few slides, but essentially a coding flaw, specifically a buffer overread, existed in the OpenSSL library, and this allowed for an attacker to generate information leakage, which eventually would result in total defeat of the protection provided by OpenSSL. The vulnerability was discovered independently by several research teams, but was published by Google on the 1st of April. Now this caused some confusion because some readers thought that because it was released on the 1st of April, it was an April Fool's joke. The optional Heartbeat extension to TLS and DTLS provides a way for the client and server to keep the connection alive and secure without renegotiating it. The requester sends a message containing a random payload, in this case potato, and a length, 6 characters. The server receives that and responds with the requested random payload. The way the Heartbeat extension is supposed to work is spelled out in RFC 6520. Hackers sometimes read RFCs, but they don't always follow the rules, and implementations are not always perfect. So if the hacker thinks, what if I send a payload of 3 letters, but I tell the server I want 500 letters? If the server doesn't match the length of the payload with the length reported in the request message, he'll return all 500 characters. And this is exactly what happens. This allows the attacker to read the memory on the server 64 kilobits at a time, and he can iterate this as many times as he wishes and read all of the memory on the server. All versions of OpenSSL from the initial release of version 1.01 through 1.0F are vulnerable. All other versions are safe with regards to this vulnerability. You should test your code to see if you're vulnerable. Here's a list of testing services. The Heartbeat extension can work in either direction. So a server can request a heartbeat from a client, like a mobile device, and this can result in what we call a reversed heartbleed. Android Jelly Bean version 4.1.1 is affected by this flaw and remains unpatched. Google has fixed the problem in subsequent versions, but many vendors have not supplied patches for their older operating systems, some even abandoning the platforms. We think there are about 50 million devices in the field that have this problem. Will the vendors ever supply a patch? As an exercise, those of you with Android devices should check your version now, and if you're vulnerable, check with your vendor for an update. For the record, iOS was never affected by this vulnerability.